it's not like it's better for me to go over the other stuff. Yeah, so this is all exponent laws. I'll do one example of exponent laws, I guess. I'm not gonna go over it in too much detail because the other part of rational expressions is more difficult. But let's start. All right, so here we have example 4. Simplify and express answers using only positive exponents. We have a bunch of different terms, and they're all the same base number. What do I mean by base number? So your base value or base number is the number, or sorry, could be a number, could be a variable, the term that has the exponent. So in this first example, can everyone please mute themselves? In this first example, x is the term or variable that has the exponent, and all of them are x's. So we can simplify this by combining all those terms into one term with a singular exponent. So how to do that? We have to follow exponential laws. Zia, if you can please mute yourself. Thank you. And the way we do that is using exponent laws. Exponent laws state that if I'm multiplying two terms with the same base value, then I add the exponent. So 2 over 3 plus 2 over 3 is equal to 4 over 3. That's basic addition. Not sure why Zia cannot mute himself, so there you go. Don't understand how that's so difficult. All right, so the first simplification has occurred. The first top two terms have been combined into a singular term. Now we have two terms that are dividing. Remember that fraction line? That means division. So exponent laws state that when I'm dividing two values with the same base term, I subtract the exponents. So the exponents becomes 4 over 3, top exponent minus the bottom exponent. That becomes 3 over 3. And we know that we can simplify fractions. 3 over 3 is just 1. So the answer is just x to the power of 1. So this whole thing simplifies to just x. So this is what it means to simplify. All right, let's do the next one. We have y to the power of 1 over 4, and then we have brackets squared. So this is an exponent laws. It's called power to a power, so an exponent to another exponent. In this example, we are not adding the two exponents. We are multiplying the two exponents. So what's 2 times 1 over 4? Well, that's just 2 over 4. And the next part is the same. We're multiplying these two fractions. Okay. There you go. Constant interruptions for no reason. I don't understand why. All right. Now, in this step, we are multiplying two terms with exponents. So we add the exponents because we're multiplying the two terms, just like the very first step here that I did in example 8. So let's add them. What's 2 over 4 plus negative 2 over 3? Well, if you remember anything about adding fractions, you cannot add fractions unless if you have a common denominator first. So let's do that. Let's multiply both the top and bottom of the first fraction by 3 and both the top and bottom of the second fraction by 4. This will give us a value of 6 over 12 minus 8 over 12. As you can see that now the denominators are common, we can clearly just subtract these two values. This becomes negative 2 over 12. And we know that fractions can be simplified. So negative 1 over 6 is the answer. The final answer is y to the power of negative 1 over 6. Hold on. There is something here that we need to take one step further, and that is the negative exponent. The answer, or the question is asking us to express answers using only positive exponents. This final answer has a negative exponent. We don't like negative exponents. So we need to now convert this from a negative exponent into a positive exponent, and that there is a law for that. And that is negative exponents. And to convert negative exponents to positive exponents, all you need to do is flip the fraction. And now what do I mean by flip the fraction? Well, if you look at the base value of the base term, it's y, right? Is y a fraction? Well, not really. I mean, it's written as just y. But can we write y as a fraction? The answer is yes. You can write any whole number as a fraction. If I have a value of 5, can I write 5 as a fraction? Yes, I can. 5 over 1. If I have a value of 100, can I write 100 as a fraction? Yes, I can. 100 over 1. So just like that, any number, any variable, if it's just a whole number, it can be written as a fraction. Just make it over 1. And now, y over 1 is to the power of negative 1 over 6. If I flip the fraction, what this does is it changes the exponent from a negative exponent into a positive exponent. So this is the final answer, 1 over y to the power of 1 over 6. Or if you just want to write it like this is also acceptable. Both are acceptable. Now, a lot of students make a mistake and they actually flip the exponent fraction. Instead of negative 1 over 6, they write 6 over 1. And that is completely incorrect. So please, I'm telling you this right now. Do not flip the exponent. The exponent never flips, ever. It's always the base value or base term when you're changing from a negative exponent to a positive exponent. All right, final example here is example C. Here we have a combination of things. We have that 2. And if you don't know anything about brackets, let me tell you something. Brackets basically apply whatever is outside the bracket into every single thing inside that bracket. So that includes exponents. So this exponent is applied to the x term, but also the 5 term. A lot of students always forget that. They always don't realize that numbers can have exponents as well, which is kind of common sense. But when you're doing this, you're usually doing it with letters, and students just forget, oh wait, numbers also have exponents. So this 2 is distributed to the 5, so this becomes 5 squared. But wait, how does it become 5 squared? Well, what's the rule when you have an exponent outside the brackets? We multiply with the exponent inside the bracket. But I don't see an exponent on the 5. And well, you're right, you don't see one. That's because it's invisible. There's an invisible 1 there. So we don't write 5 to the power of 1 because everyone knows 5 to the power of 1 is 5. But there is an exponent value of 1 there. So don't forget that. And now, what is 1 times 2? Well, 1 times 2 is just 2, so it's 5 squared. The x value also gets a multiplication factor of 2, but not the x term, but the exponent. So what's a half times 2? Half times 2 is just 2 over 2. Then we have a multiplication sign. And then we have 4x to the power of negative 1 over 2. And we can simplify the bracket first before we move on. 5 squared is 25. And x to the power of 2 over 2 is just x. And now we are multiplying this term with this term here. And we know the exponent on x is just 1. So 25 times 4 is 100. And x times x, well, you have to look at the exponents now. 1 and negative 1 over 2. Remember, if I'm multiplying two similar base values or base terms, I need to add the exponent. So what's 1 plus negative a half?